This is Food Safety First with your host, Ryan Ramdas.
Today we'll discuss reject devices on metal detection systems, how they work, what they look for, what are the pitfalls. Joining us back today is Steve Gidman, president of Fortress Technology. Welcome back, Steve.
Thank you. It's great to be here.
All right, Steve, now, in previous podcasts, we've discussed metal detectors are more than just the head itself. It's a complete system. And one of the key components of the system is the reject device itself. What is a reject device for our listeners?
Well, a reject device is anything that efficiently removes contaminated product from a production line. So once it's been identified by the sensor, in our case the metal detector, what do you do about it? You want to make sure it's removed from the production process and can't get back into that production process. And so basically in its most basic form, that's a reject device.
So that's its most basic form, but it's not a basic concept. There are many different reject devices out there, many different applications. How do you know which one to pick? Why is a specific reject device picked? What are some of the factors used to select the proper reject device for your application?
Yeah, it is complicated. They're mainly because the array of types of products that get presented to us is vast, and the speeds. So all those things, like what size is the pack, how tall is it, how tippy is it, how fast is it moving, how close is the next package, does the line start and stop? And this is just conveyors. We could go, probably don't have time today, but then we also have gravity system rejects, where even within a gravity system, there's 4 or 5 rejects that are completely different, similar, they're valves, but they're different in the design and are more appropriate or less appropriate depending on product flow rates, product densities, all those things. Same with pipelines. It sounds like we're going to have a valve there, but it's going to be this valve, depending on speed again, viscosity of products when it comes to pipe products, whether there's bone content, something that you need to cut through with the valve. So every application brings a whole array of potential pitfalls, and there's lots of opportunity to make mistakes.
So what makes an effective reject device?
Well, the first thing is it should be automatic wherever possible. So the worst reject device, which we always tell people, which is unfortunately still pretty common, is the operator involvement, where we're just going to stop a bell, ring a bell, and hope that somebody's going to come and do something about it. They'll certainly do something about the belt stopped. Whether they'll remove the product or just hit reset go, that's always the question with a manual device. It's unavoidable in some applications, but it's overused. There are many applications where we're still being asked to use a belt stop or manual reject system, where an automatic system could be applied and should be applied. So automatic is what we're going to really concentrate on, because the manual is, everybody understands it, and it's, like I said, the most unreliable reject device you can have. So on the automatic side, there's a whole array of things and features and ways and means, and perhaps for today we concentrate on mostly conveyorized systems.
Okay. Now, you said an operator, there's all these variables with the operator actually doing something with that reject versus the automatic one. If the line's running, it's automatic, and there is no operator, how do you know that a reject's actually happening?
Yeah, and that should be part and parcel of the system design. So we need to first design, if we back up a bit, we need to design a reject device that's appropriate for the package. So like I said, the package speed, spacing, the size and weight, the belt width, these kind of things will initially determine or eliminate some possibilities right off the bat. So some devices just won't be acceptable. Cover a couple of those, I hope, a little bit later on, where it looks like it would be a great answer, and it's absolutely the wrong answer. But once you've determined maybe narrowed it down to 2 or 3 potential devices, you pick the right device that you think, again, negotiating with the customer as to terms of what they feel. There's also concerns of obvious safety. We've got an automatic system. It's going to have a mechanical, usually pneumatic-driven device. And the faster the product flow, the faster that device is likely to have to move across a belt or retract a belt, and therefore right away we've got safety concerns. So we do have to make sure we get the product off the belt accurately, hopefully one at a time, and hopefully we can do that package after package. So if there's a sequence of metal detection, we can get every one of them accurately rejected off the line. That's most important. Secondly, we do it, well, probably most important, we do it safely, just as important that that's done safely. And then there's all the other peripheral things. We should capture the product. So ideally, we're going into a bin or some sort of enclosure where we can make sure the product can be safely captured, and in some cases locked so that only certain people can then recover that product. And part of the system of any automatic system can be a way to ensure that we measure that when there was a signal from the detector, that we have a feedback from a sensor that says a package, the right package, actually ended up off the line, hopefully into a lockable bin, if that's the way the system's designed. So those things can all be measured and should be. If you've got an automatic device, you really should have an automatic sensor that's telling you the device worked every time. Like you said, there may not be an operator anywhere near this thing, so nobody's witnessing this event. And so these features are all there. They're very commonplace in the market today. They're dictated on many applications by supermarkets, end users, and so forth. They're in their code of practice, and for good reason, because mistakes have happened. The reject device is far more likely to fail than the metal detector. It's just got pneumatics, electrical, it's got mechanical parts. So it's the sort of Achilles heel of
So what's the risk if a reject device fails?
Just not rejecting the right product or right products. And like, when would you find out that your reject device isn't working? If there is no operator nearby, if you don't have some sort of automatic sensing that is checking the rejects, then you won't know until the next test occurs. And that could be a shift. You could have a whole shift of product, which brings us back to other issues about how often you should test products, and we've talked about before, or test the metal detector. So you could have a failure of a reject device right after a test has been performed at the beginning of a shift. Then they come back at end of shift, and it doesn't work. We've got a whole shift worth of product that are suspect. So now you've got to store it, retract it, destroy it, rerun it, whatever you're going to have to do. So the automatic reject device, absolutely imperative where we can, but we should also be automatically measuring that it's capturing a product on every detector event that's caused a reject, that we get a feedback saying we also had a box or package.
Interesting. Now, you've touched base this a few times regarding safety. This being Food Safety Podcast, what are some of the safety issues that you're concerned about with reject devices?
Well, food safety or human safety? Two questions.
Well, both, I guess.
Well, the food safety we've hopefully addressed in picking the right design appropriate to the application. We've got a feedback reject confirm system. We got our lockable bin. We got a bin full. So from the food safety, there's a lot of just basics that need to be covered, should be covered. Some of them are obvious, some of them are not. We quite often run into applications where we have an automatic reject device, but we get product we didn't know that the downstream packaging machine stops working. They stop it, they've got a problem in the machine, and product backs right up through our device, through the reject area, right through our metal detector. The belt's still running, but we don't know what's going on. This is the problem. So one of those products that are backed up might have had metal in. Now we don't know where it is anymore because we've been tracking it by time, and if we're really smart, we've been tracking it by belt movement or shaft encoder, so we know even if somebody stops the belt, we know actually very accurately where the product is. But once it backs up through, if the belt's still running and the product's not, we now have no idea where that is. So we're going to reject something, it's going to be the wrong pack. So those are the kind of things where you go, now what? That we've designed this perfect system, and in the first hour of running, you see this product back up through the line, you go, uh-oh. All bets are off now. So that's another one of those things where you go, well, what do we do about it? And there are ways to address it. And with Fortress, we have a device called Exit Eye. So at the end of our conveyor, after the reject device, we're measuring the products that weren't supposed to be rejected go off the end of the conveyor. And if they don't show up, that's somebody's taken a product off the line, which could be a problem. But if they stay there, if there's a block in time, we'll alarm and stop the system, or at least go into fault. So you'll know exactly when this happened. So you don't have to have an operator there. You'll be told by a big alarm that we've got a problem, and that's product backing up into the reject area before it becomes a problem.
Interesting. And now what about the human safety factor?
Well, human safety factor is endless. So we, like I said, these are sometimes very, well, not hugely dangerous, but can be. You can, certainly a kicker can hurt you. A fast kicker can break fingers. A retracting belt could definitely break a hand, arm. So the risk isn't you're going to kill somebody, but it's certainly potentially very, very hurtful and not a good thing. So these, safety has to be thought into the design of the device. How is the operator going to interact with the system and not be at risk of injury? And that's quite a bit of guarding, interlocking guards, not removable guards, even reduced air pressure, and when you stop the belt, you dump the air so that the operator doesn't assume that it's okay to put their hand in there just because they've stopped the belt.
Right.
So those things all should be part of that safety system there that makes it as difficult as possible to hurt someone.
So what advice would you give food manufacturers, customers that are ready to buy a system on learning what device is suited for the application?
Yeah, it's certainly the design of the reject system is got to be a collaborative effort. We bring a lot of experience and knowledge, and so when our guys are looking at the application, that's one of the main things they'll be doing. How are we going to apply the detector, but what's the reject device likely should be? But we need to have that conversation openly with the customer. Quite often they come with a preconceived, this is what they want. Sometimes that's correct, that's the right device. Sometimes it's not, and we need to point out why it's not. So let me give you an example of a couple where customers have told us this is what they want, and then we've had to backtrack and get them out of it. So let's say you've got a bun line. So you've got unpackaged buns coming down the line, random on a conveyor belt. They're going downstream to packaging, coming out of a cooler. They're going through the metal detector, and you basically have a customer who says, I want to blow them off. Now, on a bread line, you could blow off the bread. You can use an air blast. Still probably not our first choice, but you could. There's only one product on the belt across the belt. If you apply that same thought process to a bun line, you can suddenly see, in your picture in your mind that some of those buns might ricochet. They might bounce off each other. Right. You might get the one that's got metal. You might not. And we're not in an odds game. We want to go, we've detected something. It's got to be removed. So we can't say it's 80% of the time, 90% of the time. It's 100% of the time, or it's not good enough. So that's a case where we got to backtrack and go, you know what? This is a reject device, should be a retract here. We can guarantee that everything that's on that belt is going down a trap, and we open the trap, close the trap, and everything's going down that hole. Absolutely guaranteed. And it may not even, you can also find, we've seen the situation where, you get a blade that's on the belt. So the buns are on the belt or whatever product. And if you're using a side reject like an air blast or a kicker, if it's not packaged product, you run the risk that there is a broken piece of metal on the belt that's not in the product, but it's on the belt. And if we sweep across and we knock product off, which you could do with the buns, you could still do a sweep across, you probably get the buns off. But what if there's a razor blade on the belt? We don't take it off. It continues down the line. It could end up in a package somewhere. So again, absolutely the wrong way to approach that. That's got to be a retract. No matter what's on that belt, it's going down the hole. So it doesn't have to be even in the product itself. It's going down the hole.
So shouldn't every conveyor be a retract then, based on that logic?
It doesn't have to be. If you've got packaged product, you could reasonably assume that if that same scenario occurred and you've got a box of cereal, that's your product, and you can kick off that box of cereal 100% guaranteed. Even if there was that scenario on the belt, you could reasonably assume it's never going to end up in the hands of a consumer. there are still ways around it. We could at least alarm it that there are other ways that you can look at it. But that's a reasonable assumption. But when it's not packaged product, a reasonable assumption would say it's a potential danger. And Murphy's Law will say it's going to be in the product. It'll go in.
Thank you for joining us, Steve. This was a very informative session. Learned a lot about reject devices. I guess with the right application, design, and manufacturing expertise, understanding how to build your system from the ground up is key to your metal detection system.
Absolutely.
Perfect.
Thanks.
Okay, just a reminder, please email us at foodsafetyfirst@fortresstechnology.com with any questions or concerns. Again, that's foodsafetyfirst@fortresstechnology.com. Also, please check out our YouTube channel. We have links to our podcast, various training materials and videos. So check it out.